I'm back. So today we're going to be going over Leetcode problem 968 binary tree cameras. So the main gimmick of this problem is that you're given a binary tree and then you're supposed to cover all the nodes essentially in the binary tree in the most efficient way possible. And to do that, you need to sort of minimize the minimum amount of cameras that you need in your binary tree. So for example, there's one right here where he places it in the middle and it covers all these 3 nodes, and then he places 2 alongside these nodes, and then from there it covers the whole thing. So first and foremost, we can first determine if there is sort of a concrete pattern between all these. So what I like to do is just start off by making some models to showcase what they're trying to do. My art is not good, and considering I'm making a game, this sucks. Alright, so like the first one, he places 1 here, so therefore you only need 1. He places you can also place 1 here, which also leads to 1. So in these cases, you assume whenever you have two left or right nodes available, then you would just place 1 there. For the other ones where you just have 1 linear line either going let's say this way or curved in the ones beside it, you would put 1 in the middle of it, and therefore that would be the most efficient way or manner to achieve this. However, where the difficulty really lies is determining where exactly you go if you have a test case like this, where you have this whole tree set up, and you would assume you would put it here, but if you do that, then you would have to put 3 at the bottom in order to cover them, or you would have to put an unnecessary 1 here. And the most efficient way to optimize this is placing only 2 cameras. So when I see this problem, I think that immediately you should go into backtracking of sorts to solve this, and I note down the cases that you could have. Either when you have this first case right here where there's 2 left to right nodes, then that means that you place 1. Or when you have this case, however there are left to right nodes existing, I would say that would be a case 1 where you keep continuing. And I suppose in all the other cases where your base node is sort of I guess here, but it's not optimal to place it at either one of these places, or when you have other nodes that are uncovered, I would consider them a case 0 where they're just uncovered and not protected. Alright, and now that we have everything, I think we can start off by actually coding this and figuring out the best solution possible. So we need to keep track of our cameras, first of all, and we also need to have, actually hold on, let me put this in the private class, and we need to have some sort of definition. Actually, no, not private, my bad. We need to have some sort of way to go through the binary tree, as I was saying, but like I don't think that just putting it in camera cover is going to be optimal in terms of like just traversing the whole tree. I think it would be much more cleaner if we have like another sort of like node, something, I don't know, like another function to write this all down. Alright, so here's a backtrack function. Sorry, here's our backtrack function, and from there we can figure out what to do. So if our root is null, then we can just return like 2, meaning that null nodes are covered, which would be our case 0. Then we can do this where we can get like the left side and right side of the binary tree, and then from there sort of keep going to figure out what exactly is the pattern. Yeah, so I think these are like the best way to sort of, I mean, these like recursive calls are the best way to sort of traverse this root, and also like keep in mind the original return value and sort of store it for the future. Right, and then next we need to determine if our values are correct. Actually, no. Oh, wait. I remember why. I kind of threw myself earlier by saying this is the case 0. It was clearly 2. I'm getting too tired. Okay. So our base case is like our current node is uncovered. So if left equals 0 or right equals 0, then we can say that we can place a camera here and then return return 1, meaning that one camera is placed. The second case is if we place one camera down or right camera down, we can just return, meaning that like our nodes are covered in cases like this one. And then I'm pretty sure it should work. Like return 0 should be the base case of sorts whenever there are both these are covered. Alright. So from there we need to call our function. No. Oh wait, no. I forgot. The base cases only cover for the camera cases, not the actual count. Okay. So considering that if if it is 0, then we can just place 1. And if our original root is like empty, then it should return 2, meaning that cameras will stay the same. Okay. Yep, just like that. That's, I think, the best way to solve this problem. Hopefully. Hopefully I'm right. Peace.